Hello everyone, this is Dharamveer sir here. So today we are going to start with chapter 1 of grade 11th maths, which is sets. Okay, and the topic for today's video is sets and their representation. That is, what is the meaning of set? Okay, and how to represent a set in different forms. So today we are going to learn about sets and their representation. Clear? So let's start. So first let me tell you what is a set. Now a set is a well defined collection of objects. Now well defined collection of objects. So first let me tell you what is collection. So if you collect, so we have already learned about collection like stats in grade 9th and 10th. Now collection means if we are collecting different objects, suppose I am collecting the name of boys of my class, or I am collecting the height of the girls of my class, okay, or if I am collecting the data like date of birth of my students. So it is a collection. Now coming to well defined. Okay, so well defined means a collection which should be suitable for everyone. The definition should be clear for everybody. Suppose I am saying that Dharamveer sir is the best teacher. Okay, so it is not clear, it is not well defined. Because Dharamveer sir may be best in my view, but Dharamveer sir might not be the best in somebody else's view. So there is a contradiction. So when we define a set, then it should be applicable by everybody. Okay, it should be approved by everyone. Clear? So that is the meaning of well defined. So whenever we say set, it should be well defined collection of objects. Clear? Well defined means accepted by everybody. Clear? Now there are some points that objects, elements and members of a set are synonyms. Okay, so if I write a set and I say that these are the elements or these are the members or these are the objects, all means same. Now sets are denoted by capital letters. Clear? So whenever we write a set, we denote the set by capital letters, A, B, C, D or whatever. The elements are denoted by small letters. Okay, so whenever we write the objects, elements and members, we represent them by using small letters. If you see, if an element of a set, we say that A belongs to A. Now if you look at the video, the belongs means sign is there, that is called epsilon. Epsilon is used to denote the phrase belongs to. Thus we write A epsilon A. It means A belongs to A. Clear? And if we say that B epsilon cross A, then we say that B does not belong to A. I hope I am clear. So pause and note down these points. Now I told you that today we are going to learn about how to represent set, that is representation of sets. So there are two different ways of representing a set. Okay, two different ways. First is called roster or tabular form, and the second one is called set builder form. Now let me tell you what is their meaning. Now when we say roster form, then in roster form all the elements of set are listed. Okay, we simply write the elements in braces, that is middle bracket, and separating the elements by commas. For example, I have written the set of all the natural numbers which divide 42. Then the set is 1, 2, 3, 6, 7, 14, 21, 42. Okay, all are written in the middle bracket, that is called braces, and all the elements must be separated by comma. And in roster form, the order of the elements does not matter. You can write the above set as 1, 3, 7, 21, 2, 6, 14, 42, whatever order, just you need to write all the elements separated by commas. You can write 42 in the first and 1 in the end, it doesn't matter, but you need to write all the elements. And in roster form, we generally not repeat the elements. Okay, like I have given the example school. Now the elements of this set will be SCHOL. So I am not going to repeat O two times because in the school there are two O's. Okay, and this can also written as SOLC. It means the order does not matter. So roster form means simply writing all the elements in the middle bracket, that is called braces, and separating the elements by commas. And in roster form the elements are not repeated. If you repeat them, it's your wish, it's not wrong, but generally we never repeat the elements. And the order of the element does not matter. You can write any element anywhere, just remember to write all the elements. Clear? So pause and note down the points. Next we have set builder form of set representation. Now in set builder form, all the elements of the set possess a single common property that is well defined. Okay, in the term, while defining set, we told you about well defined. It means a proper property, common property, which is not possessed by any element outside that set. Okay, if I am saying that we have to write all the natural numbers between 1 to 10, so it simply means between means what? Excluding 1 and 10. So we will get the set 2, 3, 4, 5, 6, 7, 8, 9. Now we cannot say that 13 possesses this property. Okay, so set builder form means simply defining the property by which the elements are defined. I have given an example. We have a x. Now look at the bracket. X means the element. That double dot means such that x is a natural number and x lies between 3 and 10, that is 3 less than x less than 10. Now we read that the set of all x such that x is a natural number and x lies between 3 and 10. So the numbers will be 4, 5, 6, 7, 8 and 9. Okay, if you look closely, I have denoted this set by capital letter. So in the beginning I have told you we denote a set by using capital letters. I hope I am clear. So pause and note down the points. So here I have given few examples of sets we use in math. Okay, like n, all the letters are capital. N means the set of all natural numbers. Z means the set of all integers. Q, the set of all rational numbers. R means the set of real numbers. Z plus means the set of positive integers, and likewise if we have Z minus, it means the set of negative integers. Q plus, it means the set of positive rational numbers, and R plus means the set of positive real numbers. If I have W, it means the set of whole numbers. Okay, so you need to know these denotations because somewhere in the entire textbook we might be using these symbols. Okay, so please note down the points. I hope I am clear with the definitions. So let's begin with exercise 1.1. Now question is, which of the following are sets? And justify your answer. Remember, set is a well defined collection of objects. Remember that term, well defined. Okay, so I have solved few sums for you. First is the collection of all the months of a year beginning with the letter J. Now if you collect the months starting with J, it means January, June and July, and it is well defined that nobody can argue that no we can include August in this also. Okay, because it is well defined, it should begin with letter J. Since it is well defined, therefore it will be a set. Okay, third is a team of 11 best cricket batsmen of the world. Now the term best, it simply contradicts because Kohli might be best for you, but Sachin might be best for me, Rohit might be best for some other person. So here it is a contradiction, this is not defined. So remember that best is not the well defined term, it cannot be accepted by everyone. So since this definition is not accepted by everyone, so this cannot be a set. Okay, sixth is a collection of novels written by the writer Munshi Premchand. Okay, now if we collect all the novels written by Munshi Premchand, nobody can argue, nobody can say that this is written by Shakespeare or this is written by Dharamveer sir. Okay, so this definition is well defined, nobody can argue with that. Okay, so since it is well defined, so it is a set. So I have solved only 3 parts, so other parts are for you. So pause and note down. Moving to question number 2. Let A is a set given by 1, 2, 3, 4, 5, 6. It means the elements are given, so it is a roster form. We have to insert the appropriate title, belongs to or does not belong, in the blank spaces. So if we look at 5, is 5 there in the set A? Yes, so we'll write 5 belongs to A. Now if you look at 8, is 8 there in the set A? No, so we'll write A does not belong to A. So in this way you can simply write the belongs to or does not belong to in the appropriate blank spaces. It is very simple. If the element is there, we will write belong. If the element is not there in the set, then we will write does not belong. Clear? So pause and do the sums. Moving to question 3. Write the following sets in the roster form. Roster form, what? We used to write the elements in the braces separated by commas. Now first we have A equals to X such that double dot is yours, such that X is an integer and minus 3 less or equal to X less than 7. Now X is an integer greater or equal to minus 3 but less than 7. So the numbers will be what? Minus 3, since X is equal to minus 3 also. So minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Why not 7? Because X is less than 7. Okay, so we have the elements, so we need to write in the roster form, and the roster form was what? We need to write the elements in the braces separated by commas. So in roster form the A will be given by minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6 in the braces and all separated by commas. Clear? So in the same way we have fourth part. D equals to X such that X is a prime number which is a divisor of 16. Okay, so we have a well defined term. Now the questions A, D and E, what are? They are written in the definition form, that is they are set builder form, and we are converting set builder form into roster form. Now we have to find the divisors of 16, prime numbers. Remember that, prime numbers. So first find the divisors of 60, which are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 16. Now since we need only the prime numbers, so the prime numbers out of these is 2, 3 and 5. Remember that 1 is neither prime nor composite. So we got 3 elements only, 2, 3, 5. Therefore the roster form of this will be what? 2, 3, 5 in the middle bracket. Done. In the same way we have fifth, the set of all letters in the word trigonometry. Now remember that we don't repeat the elements. Okay, and order does not matter. So simply write the alphabets in the middle bracket. So E will be equal to what? T, R, I, J, O, N, M, E, Y separated by commas in the middle bracket. Clear? So solve all the other parts. Next is question 4. Write the following sets in the set builder form. It means here we have roster form given and we are going to write them in the set builder form, that is using the property. Now here the elements is 3, 6, 9 and 12. So all are multiples of 3, 3 1 ja, 3 2 ja, 3 3 ja and 3 4 ja. So we can write the set as X element such that X is equal to what? 3n, multiple of 3, it means 3 multiplied by some number, 3n. N is what? 1, 2, 3, 4. So n means natural number. So n belongs to natural number, but also we have to apply that this natural number is between 1 and 4. So 1 less or equal to n less or equal to 4. Because if we are not writing 1 less or equal to n less or equal to 4, then n can be any natural number. So we are going to restrict that also. Clear? Same is second. We have 5, 25, 125, 625. So this is what? Exponent. 5 power 1, 5 power 2, 5 power 3, 5 power 4. So again in the exponents we have natural number. So we'll write the set as X such that X is equal to 5 power n. N means what? Natural number. So n belongs to n. N was capital N is natural number set. And here n also belongs to 1 less or equal to n less or equal to 4. Clear? Next is fifth. We have 1, 4, 9 up to 100. So you can simply identify that they are the squares of natural numbers. So 1, 4, 9 up to 100 is what? 1 square, 2 square, 3 square up to 10 square. It means we are taking the squares of natural numbers up to 10. So X will be, the set will be what? X such that X is equal to n square, where n belongs to natural number n, and here n is from 1 to 10. So 1 less or equal to n less or equal to 10. Clear? So pause and solve the other sums. Next we have question number 5. List all the elements of the following sets. Okay, we have to write the elements. Here definition is given. So again we have a set builder form and we are going to convert them into roster form. So first is A equals to X such that X is an odd natural number. Okay, odd natural number. So odd natural numbers are what? 1, 3, 5, 7, 9, 11, 13, 15 up to dot dot up to infinite. So we are going to write A equals to, in middle bracket, 1, 3, 5 up to infinity, dot 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 and so on. Okay, because there is no end, so we simply need to write dot dot dot. Third is C equals to X such that X is an integer and X square less or equal to 4. So we have X square less or equal to 4. So we have to think of integers whose square is less or equal to 4. So it is simply that minus 2 square is what? 4. Minus 1 square is 1. 0 square is 0. Again 1 square is 2 and 2 square is 4. So the integers we are getting is minus 2, minus 1, 0, 1 and 2. Clear? So we are going to write C as, in middle bracket, minus 2, minus 1, 0, 1, 2, all separated by commas. Clear? And sixth is F such that X is a consonant in the English alphabet which precedes K. Precedes K matlab K ke pehle, and the consonant. So the consonants before K are what? B, C, D, F, G, H, J. Therefore writing in the roster form, F will be equal to B, C, D, F, G, H, J in the braces, that is middle bracket, and all the elements separated by commas. Clear? So pause the video to solve the other sums. Next is question number 6. Match each of the set on the left in the roster form with the same set on the right described in the set builder form. Okay, so we have roster form and set builder form and we have to match them. So first we are going to convert the set builder form into roster form. So A is what? X such that X is a prime number and a divisor of 6. So divisor of 6 and prime number. So A becomes what? 2, 3. B is X is a odd natural number less than 10. So odd natural numbers less than 10 are what? 1, 3, 5, 7, 9. So B becomes 1, 3, 5, 7, 9. Done. C is X such that X is a natural number and divisor of 6. Natural number and divisor of 6. It means 1, 2, 3 and 6. Done. And D is X such that X is a letter of the word mathematics. So writing the alphabets in mathematics and without repetition, we will get M, A, T, H, E, I, C, S. Now we can simply match. 1 is equal to what? 1 can be matched to C, second can be matched to A, third can be matched with D, and the fourth can be matched with B. Clear? It is very simple. If you convert the set builder form into roster form, easily matching can be done. So pause and note down the solution. So with this we end with exercise 1.1. I have solved few sums and other sums and examples before exercise 1.1 you need to solve. Clear? Okay. So thank you and all the best.